We've seen how to graph using horizontal and vertical shifts. If we know a quadratic function looked like this, we would know that there is a horizontal shift, right 3. That value goes the opposite direction we expect. Negative actually moves the graph right. And a vertical shift, the outside number, is exactly what we expect. It's positive, so we go up 4. Well, that's a very concrete, they give us the numbers example. We can also take two functions and write equations even without having this concrete example with just numbers. We can write one equation in terms of another. So here we have two graphs, and they just call them f of x and g of x. They don't give us the actual equations, although we know when a parabola starts in the center, it's that basic parabola, so it's probably just x squared. But we want to write g of x in terms of f of x. So we have to see, well, how did the graphs change? What happened from red to blue? I usually look at the vertexes to determine that. I say, here's our original vertex. What happened to get to our new vertex? Well, we went up 2. We know a vertical shift is outside and it's positive, like we had our up 4 here. So when we want to write the equation of g of x, we want an equation for g, so we're starting with the letter g. It's going to be the original red graph, which they called f of x, and they moved it up 2 spaces. What if we had a horizontal shift instead of a vertical shift? What if our graph ended up over here? So originally we're in the center again, and this time we go right 5 spaces. Well, we know right 5 is a subtraction inside the parentheses, and if we're writing a new function called g of x, I'm going to call it h of x actually, let's use a different letter. I'm going to call this new one h of x. It was the original red graph, f of x, and it had a horizontal shift, so inside of the parentheses, right 5. So we can write these equations in a very general format using our function notation.